Right, the school graphs exam 2014, this is question 3. Students are selling firewood to raise money. They charge $80 per cubic metre up to 3, and then $50 per cubic metre for any further after that. You must buy whole cubic metres. Right, so it's $80 per cubic metre, so 1 would be 80, 2 would be 160, 3 would be 240, up to 3. Then for any further ones that you buy, so after 3, if you buy another one, it changes to add only $50 onto that. Now we're adding 50, whereas initially we were adding 80. Right, now I'm asked to draw the graph. C for the charge up to 10 metres cubed. Right, so 1 costs 80, 2 costs 160, 3 costs 240, then it changes. 4 costs 290, the next one is 340, we want it up to 10. Right, once again it's discrete because you can only buy whole cubic metres, so it's definitely not continuous. We can see the $80 per cubic metre and then the $50 per cubic metre, which is slightly less steep. So for part 2, it says how does the change in price per cubic metre after that affect the graph? The graph becomes less steep. The gradient has changed from $80 per cubic metre down to $50 per cubic metre, and the graphs become less steep. Equation for the total amount after the price per metre cubed, so that's once it becomes 50. Y equals mx plus c. You can put the numbers, of course, into stat. The gradient's clearly going to be 50, and putting the numbers into stat will help you work out the y-intercept. So we had 4 gave us 290, 5 gave us 340, and so on. Times multiplying by 50, would be 200, plus I'd have to add another 90. 4 times 50 is 200 plus 90. So we're adding on 90 each time, and of course the calculator gives you that as well. Now thinking about variables, certainly C for charge. It didn't really have a variable for the metres cubed. We could probably define one. A lot of people used metres cubed. Or you could use X. There should have been a defined variable for the wood. Right, now we've got an equation. We could make up a table, go into table on the calculator, put in that formula, just the this right hand side of the formula, 0.1 times x squared minus 4 times x plus 50. We could set it to go from 0 to 40 in steps of 10, or you can substitute each individual number in. Now I want us to graph that. Now this time, for the first time, you can actually make it continuous, because it is possible to talk about this distance away from the side. So graphing the points, and there's my chain. Oh, it's not very good at all. Chain hanging down. Go back and fix that up. So it's okay to talk about 5.6 metres away from the trailer, 22.1 metres away from the trailer, and that's why we'd make it solid. It did say to make sure it's clear that the chain starts from here and finishes here. Normally when we drew graphs, it's really important to keep it going beyond the last point. The part 1, next part of the question, says how far above the ground is the point where the chain is attached to the trailer. So 50 centimetres above the ground. And the next part to that was how far above the ground is the chain at its lowest point. 10 centimetres. I need both of those. Now part 3, we'll keep going here while I've got the graph, although perhaps we could use a different colour. I'm talking about a second chain, attached to same height off the ground, same distance off the ground at its lowest point, but the distance between them is only 20. So that's what it's going to look like. We've got 3 points, 0, 50, 10, 10, and 20, 50. So putting those 3 points into the calculator in STAT, asking for the equation y equals 0.4x squared minus 8x plus 50. Just check the variables, although they didn't really state any, so it would be safe to use y and x in this instance.